vectors today. Three-dimensional vector. You know, the two-dimensional ones, just the X and the Y coordinates are not that bad. Okay, we were exposed to those a lot in physics. Okay, so we're going to take another step here. And I'm going to show you a way to look at describing 3D vectors and breaking those three-dimensional vectors into their components. So to do this, let's start off with a three-dimensional X, Y, Z coordinate system where we have X, Y, and Z. Okay, so we've got our coordinates. Now on this X, Y, and Z, we're going to put a force. And I'm feeling purple today, so we're going to put a force F. Okay? So we can keep it separate from our axes. Now, we want to find the components of F. So our assignment is find F X, F Y, and F Z. Now, I know I've got a two-dimensional board and it looks like this has just got an angle with respect to the Y-axis. But in reality, what I'm trying to illustrate is that's coming out like this. Okay? It's not in the ZY plane. It's kind of coming out in all three dimensions. Okay? So there's different angles there associated with it. Something we would experience in a three dimensions. Okay. So how can we approach this? Well, we need to find these, so we need to find I, J, and K unit vector components, okay, within this thing. So, okay, so here we go. So let's draw some things on here. What do we know? What do we know? Well, do we know positive directions? Yes. This is going to be the positive X direction, the positive Y direction, and the positive Z direction. What can we presume that we know? This is the negative X direction. This is the negative Z direction. And this is the negative Y direction. And you're thinking, oh, yeah, I know that. Okay? So now, what we want to do is find some angles. The angle between F and the Z-axis is called theta Z. Okay? And I'm going to show you why that's important. Then we're going to find the angle between the x-axis and our projection. Now, if we've got, I really don't have anything to demonstrate this other than my little ruler here, okay? If this is our force, out like this, okay? If we're standing above this Cartesian coordinate system, and we're looking downward, there would be a shadow that's given off by our ruler, right? Where would that shadow fall?
On the
XY plane, right? So I'm going to illustrate this in purple. As my shadow. Okay? Now, since I'm illustrating there, that shadow is going to form an angle between the x-axis and the bottom of that shadow, or the bottom of that projection. And that angle is phi. Okay? So now I have two new angles. In a two-dimensional representation of a vector, I've only got an angle theta, right? Between x and y. It's two-dimensional. With three-dimensional, I've got more angles. More descriptions because I've got three parts that I have to come up with, okay? So, F is gonna equal to the square root of the x component squared plus the y component squared plus the z component squared. Not much of a difference from what we've already done, okay? We just added that third dimension. Now, how do we go past that? How do we go past that? Let's think, okay? What do we need to know? We need to know fx, fy, and fz.
I think I can figure out the FZ, like an equation for it.
Okay, well, just don't give me an equation, but think about what we want to do. We want to find those out. And they're based on an angle component of f, right? Okay, so if we look at f, x, what is the x component equal to? It's equal to f times the cosine of what angle?
B?
Phi, okay? Why is it that angle phi? Because that's the angle with respect to the x-axis, right? Don't plug in theta z, because that's the angle with respect to the z-axis, okay? So as we add more to it, we've got to be sure what we're gonna find as far as our components go. So fy. Now, what is fy? I should put that, okay, just to indicate that it's a vector there. What can we find for fy? Well, let's take and draw a free body diagram, okay? Get rid of some of this clutter here, okay? And we're gonna draw a free body diagram. And here's our free body diagram. Can I scoot this up, y'all here? Try the Hawaii 5 and see if it works, okay. This is speed, and this is the shadow, right? The shadow. You agree with that?
Yeah, okay, that is,
That is the shadow.
I'm referring to the angle, why, it looks like it says.
Oh, it says Q, I'm sorry. It should say Q. Okay? Now, we know a little bit of trees, right? If we've got one vector, this is the x component of that vector, and this is the y component of that vector, right? And we know that what? Sine, our cosine is equal to what? Of any angle is equal to what? Adjacent over hypotenuse. What does sine equal to? Oh, I forgot hypotenuse. So if we've got the cosine of this, it's equal to the opposite, which is what? F of x over c, over F, the shadow of F, right? What's the sine of this equal to? F of y over F.
And then Z seems coming from that.
Well, right now we're just doing x and y, and we'll get to z because z's special. It's got its own angle.
Yeah, and
Okay.
it's just one of the trig functions to get there.
Yeah, so, but right now we're just looking at x and y. Okay, so we can rearrange these equations so that we get this, right? F of x is equal to cosine theta times f. F of y is equal to f times the sine of phi.
line that's going down from water?
Okay, it's not going down, it's actually coming out. Okay, it's coming out, but I've only got a two-dimensional board. Okay, if I had a hologram, then yes, but they won't buy me a hologram board, I'm sorry. Of course, I wouldn't use it to do statics problems, I would come up with something fun. I don't know what yet, but it would be a lot more fun than the statics problem. Okay, this X is actually, should mean it's coming out towards us. And the Y is going along the plane board. Okay,
We're looking in the Z direction right now, pretty much.
right. Well, if it's written this way, the Z direction would be coming out and
Yeah,
that
we're
would be
looking
going
down Z.
But we're rotating it up.
Yeah, we're
where
looking
X is
kind of,
coming out.
we're looking kind of down at it from like,
We're above it, we're
Yeah.
looking down from above.
yeah,
right?
we're looking down the Z axis.
So these would be the shadow of F. Okay, the shadow of F.
Seems, well, if we are going with shadow logic, the light source is directly above, which means,
Or we're setting above, okay? So now we've got Fx and Fy, so let's look at Fz. I'll draw it over here. Okay, for Fz, we've got the Z axis. I haven't been drinking, I promise. There's the Z axis. I did. I'm gonna have to get a diet Dr. Pepper this morning. Okay. This is angle theta Z, and this is F. Okay, with respect to the Z axis. Okay? Now, where is our relationship here? This is what type of relationship?
hypotenuse adjacent cosine.
Cosine relationship. So the cosine of theta Z is equal to what?
F of Z over F.
And in this case, it's not F of H. I mean, F of S, the shadow. It's F, the actual F, right? So we can rewrite this and say that F of Z is the cosine of theta Z times F. So now we've got our three components, right? We've got our three components. But what do we know?
We don't know really
We don't know anything.
anything.
We don't know anything. Why do we not know anything? Because these two, there has to be a relationship to this one.
Mhm.
Because this F is different than the shadows, right? Agree? If we've got this relationship here, where is the shadow at?
Be
It's gonna be under it, and it's gonna look like this, right? Okay, so could we not say that the sine of theta Z is equal to F Z over F of the shadow? All we've done is a trig relationship there. Remember, the cosine of one angle with respect to this axis is equal to the sine of the other angle with respect to the opposite axis. So now we have this relationship, which is F of Z is equal to F of S times the sine of theta Z. So we've got this relationship, and we play in Hawaii 5-0 again, sorry. Okay, that relationship. Now, you've got three equations and three unknowns. What can you do? There's two options here, right? What are the options? Okay, let's back up. You have two equations and two unknowns. What are your options? Solve one equation with respect to one of the variables and substitute in, right? Got three equations with three unknowns. What do? What's the easiest way to do? Solve one of the equations with respect to one of the unknowns and
Plug it in.
plug it in.
Okay.
Okay?
So what do
Or we can do a matrices. That's what I thought. Okay? Three equations, three unknowns. We're gonna save the matrices. Okay? So we've got three equations and three unknowns. Okay? Okay, so how do y'all wanna substitute? Which one do you wanna substitute for? How about taking this relationship couldn't we say that f of z over f of s is equal to sine of theta z? Yes, could we do that?
Could.
Could we also say any other relationships?
We could. We could say f of s is equal to f of z over sine.
Of theta z. Right? Can we plug that into a relationship? Yes, we can plug it into f of x and f of y, right? Agree? What was f of x? Was f of that, right? So could we not just move that up there and plug it in? Okay, so that f of s is equal to okay? Now, when we approach these, okay, we've got to realize that we will be given the angles. We will be given the angles, okay? Or we're gonna be given F. One of the two, okay? And one of the angles. So you're gonna end up with three variables, you're gonna know two of them. 90% of the time, I'm not gonna say any greater than 90% of the time, 90% of the time you're gonna know the angles or have a method to figure out angles. Okay, so let's look at an example on how to do this. Okay, let's look at an example on how to do this. So, draw another one here. Get my drawing right, okay? I tell you, I need to do something here. Okay, let's say I have a solid bar at the origin here. Kind of like I don't know, I'm thinking of a fence post. Okay? Now, on this fence post, we're gonna call this fence post A. Okay, and it is vertical. Okay, so we've got a post in the ground, okay? XY is the ground, the vertical is Z. Okay, so you got that in your mind. Okay, we got a fence post there. Well, on this fence post, we exert a force. A force B. This force B is equal to 2,500 newtons. That force B is 2,500 newtons. Now, force B is this distance from where it's being exerted is 40 meters. Okay, so got our fence post. We've got our Dr. Pepper bottle out here, okay? It's in the X and Y plane. Okay? X, Y. Okay, so we get on our plane and we're out here 40 meters away from this plane, from the X, and we're doing what? We're exerting a force. Okay? Now, how would you exert a force like that? How would you apply that force? Obviously, if you're 40 meters here, you're a good distance here, your arm's not long enough. How would you exert that force?
Is it a?
You'd have a rope and tension, right? Or cable, right? Or you'd telepathically do it, right?
Jedi powers.
Okay, or shoot it with a rifle or something, okay? So you'd have some type of interaction there. Now, if the force was in this direction,
You'd be pulling on it.
you'd be pulling. So you can't push on a rope.
Long stick.
A long stick, yeah. You know, I imagine there's a snake sitting on top of the and you didn't bring your gun, so you got you a long stick.
Trying to get it.
That's a really long stick, because you're 40 meters, that's about 120 feet from yeah, you got a long stick, okay? So, now we've got these forces,
Just try.
okay? Now, the length of this to here is 60 meters. So you're 40 meters from the Y, and you're 60 meters from the Z. Okay? Does that give you anything in reference to coordinates?
Okay, so your
So you've got some coordinates, right?
Y coordinate would be.
Think about it. Don't answer it, just think about it. Would that give you any coordinates? Okay? And what we want to do is find the X, Y, and Z components of this force. We know the force total is 2,500 newtons. So F of BX plus F of BY plus F of BZ has to sum to 2,500 newtons, right? Not less, not more, but it's gotta be equal to that. So, we need to break this down. We're gonna break this down using the unit vector U, which is made up of I components, J components, and K components. Now, what do we remember about our unit vectors? A unit vector is equal to what? 1, or unity, right? We multiply by it, it doesn't do anything except break it down into components. It doesn't change the value, okay? So, now, F is equal to our unit vector. We haven't done anything, right? Our force is equal to our force times our unit vector. Agree? So our force is equal to the force exerted between point A and B times our unit vector. All we're doing is just making it a little bit more important, okay, or more specific to what we're doing, okay? You got any questions up to that point yet? Now, we must find our unit vector. How can we find our unit vector? I kinda hinted to it a while ago. We've got some coordinates on our drawing, right? Agree? So where is B at? What are the B coordinates? What are the X, Y, and Z for B? What's the X coordinate for B? This is positive X, so that's negative X. It's 40 meters above negative X, right? So B would be negative 40 for the X.
How do you get above the, oh, is that like out?
Okay, think about this. Think about my Coke bottle here, okay?
It looks like.
X is coming out here, Y is going along here, the line is back here.
Oh, this is.
40 meters behind, 40 meters behind, not 40 meters above, 40 meters behind, okay? Now,
Okay.
what is the Y component? I've got 60 meters above, right? So the Y component is 60. Where is that post at? Right on the center line of what axis? Z axis. So if it's at the center, Z axis, what's the Z coordinate? Okay, now what's A? It's 0. It's 0. Now, its Z component is the height of that post. It's the height of that post. And I forgot to put the height on that post, but the height of that post is 80 meters. Okay? So now I have what? I have a way to find my unit vector. I can do that by subtracting what?
Your
B and A.
Your resulting
Yeah.
point from your
So
initial.
my B
Wait,
is negative 40 minus 0, which is what?
hold on,
Negative 40, right? So I have
wait a minute.
Negative
it's-
40
Isn't
I.
isn't it final minus the initial and we are pushing at A?
It's force B minus force A. Force B is the final force. A is stationary. A is stationary. We're exerting the force to A. So it would be B minus A. Okay? Now, what would the second component be? Plus 60 J hat. What about the last component, the Z component? Minus 80 J hat. So now I have a unit vector. Now I have a unit vector.
I
Okay?
understand. Okay.
Now I've got a unit vector. So I can do some math. Okay? Now I don't know if you experienced this. I know you didn't experience it in physics. Okay? So if you might have experienced it in a math class. So let me show you something. Okay? I can take vector AB and divide it by the magnitude of vector AB, and I can get a relationship, okay? I can get in a relationship. And that relationship is gonna let me calculate some more numerical values that simplify my force, okay? So, what is vector AB? It is how can I find the magnitude? How can I find the magnitude? a vector 80. Yes, sir.
Shouldn't, that be the unit vector? I mean,
Well, that is the unit vector.
so why,
So what is the magnitude of the unit, what is the unit vector over the magnitude of the unit vector?
the unit vector?
Unit
It's equal
vector
to
is-
one, it's equal to one, but is it just one? Is it just a number one? Or is there a relationship there? Is there a relationship? I want you to think about this. There's a relationship there. Okay? There's a relationship there. Okay? What is the relationship? I divide by the magnitude. How can I find the magnitude of the unit vector? That's the easiest question.
Do the square root of all those squares.
Square root of all those squared, right? So this would be equal to the square root of negative 40 squared plus 60 squared plus a negative 80 squared. Okay? Which is equal to what? The bottom is equal to 107.7. Okay. So negative 40 I hat plus 60 j hat minus 80 k hat divided by 107.7 gives me negative 40 over 107.7, which is what? A negative 0.371 I hat. 60 over 107.7 is
0.5571,
I'm just 3 digit 0.55.
yeah, 0.557.
And then 80 over 107.7, be a little bit smaller than that, or bigger than that, I'm sorry. A little bit less than 0.8, a little bit less than 0.75.
Point 742.
2?
It looks like 0.743 on my end. Is there an 8 behind the 2?
2, 3. How about we put a question mark over there?
Because it looks like there's
Makes us feel better, okay? Now, okay, now, why do we need that? Why do we need that? Because we know what? Our force is equal to the force times the unit vector, right? What are we trying to do? Break it into
components.
components. So this is 2,500 newtons times 0.371 I hat plus 0.557 j hat minus 0.743
Isn't the
k hat.
0.371 negative?
It is. Okay, sorry. Okay. With that, now what can I do? What can I do? We can yell about waking up if we're in physics, right? What's the x component? This times that, right? What's the y component? This times that. What's the z component? That times that. So the x component is 2,500 newtons times a negative 0.371 I. The y component is 2,500 newtons times 0.557. The z component is 2,500 newtons times 0.742 or 0.743 k hat, right? Depending on what calculator you have. What were we looking for?
Our components.
Our components in the X direction, the Y direction, and the Z direction. Okay? Does that give us our components in the X direction, the Y direction, and the Z direction?
Mm-hmm.
Yes. I tells us X, J tells us Y, and K tells us Z. That's all we have to do, to break it down into a from a three-dimensional picture into the three-dimensional components, okay? Now, I don't think I gave you a three-dimensional homework problem, did I? No, I think they were just two-dimensional, the two problems that you have for homework. So Monday, we will, work a three-dimensional one for our problem, okay? I am
Would it be
thinking.
times negative 0.743 because it's
Yeah, I
times?
gotta do that.